So we've got dilations. And today is 10-3. Okay. So a dilation is, like we saw on the agenda page, it is the enlargement or reduction of a figure. Enlargement or reduction. Let's see, Serenity, go ahead and close that until we're done with the notes. The thing that either enlarges or reduces the size of the figure is called the scale factor. Scale factor here. Scale factor. It indicates how much the figure will either get larger or reduce in size. Scale factor is probably something you've used before, actually. What's that? No? Maybe? Probably. The scale factor is represented by a variable, and we use the variable k. Lowercase k is what we use for scale factor. So when you're describing the scale factor of something, if it gets twice as large, you would say like k equals 2. If it becomes 1/4 the original size, you would say like k equals 1/4. So that's what we're talking about there. So if the value of k is greater than 1, what do you think happens to the original figure? Does it get larger or smaller?
It gets bigger.
It gets bigger. So that would be an enlargement. So if the value of k is greater than 1, whether it's a whole number or a decimal or even a fraction, sometimes improper fractions, right? Improper fractions have values greater than 1. So pay attention to that when you're working through this, because sometimes it'll say, let's see, I'm going to find one real quick because I think there is one on here. Yeah, so on number 9, it says the scale factor is k equals 3/2, 3/2. Because the numerator is larger, that means this is an enlargement, even though it's written as a fraction. Same thing with number 5. 5 would also be an enlargement because 5/2 is more than 1. So just because it's written as a fraction does not mean it will be a reduction. But when k is less than 1, it is going to be a reduction. Now, I didn't really include everything I probably should have when I said k is less than 1, just because you won't see negative numbers. So it's still greater than 0, but it's less than 1. So it's, any fraction or value in between 0 and 1 is going to indicate a reduction in size. So that's what we're going to be working on today. A lot of these are just giving you points, and then what you are going to do is kind of like with translations where you added or subtracted values to the x's and y's. With enlargements or reductions, you're going to multiply every single value by the value of k. That's it. And that will give you your new image. So for number 1, let's just get our triangle on here, RST. So we have r at -5, 1, 2, 5, and up 1. And by the way, these graphs are different size than the ones we've seen so far. Everything we've seen so far is like an 8 by 8 by 8 by 8. These are all 10 in each direction. So let's see, -3/4 is the next one. 1, 2, 3, and then 1, 2, 3, 4 right here. And then we've got -2, 1. So we have R, S, and then -2, 1 is here for T. So these ones aren't necessarily going to be moving the shape around the graph. Oops, that's not the right place. I did -2, 1 instead of 2, -1. Sorry, 2, -1. There's T. You know what? I'm just going to get a new piece of paper for this. So 2, -1 for T. T's down here. Let's see. -3, 4. There's S. And -5, 1 for R. Okay. So here's our pre-image. And what we're going to end up doing is doubling all the values for both the x's and the y's of R, S, and T. And that'll give us our new values for our image. So everything with R gets multiplied by 2. So that would be -10 and 2. Same thing for S, -6 and 8. Same thing for T, 4 and -2. So just double all the values. Multiply by whatever the value of k is. and then graph those points. So negative 10, 2 for R prime for the image. All the way to the left and then up 2, there's R prime. S prime is at negative 6, 8. So there's 5, and then there's 6, and then 8 would be here. So there's S prime. And then T prime will be at 4, negative 2. So 3, 4, 1, 2. There's T prime right there. And what we'll end up with is the exact same shape as the original. It just ends up being double the size. Each side length is now double the size as it was before. So that's number 1. I'd like you to try number 2 on your own. Got a rectangle, and it's basically going to become 3 times the size. So there's our pre-image in red. And then all of your image values should be right here in blue. So A prime is going to be all the way to the left at negative 9, 0. So there's our image value of A prime. B is at 3, 6. So there's B prime up here. C prime is at 6, 0. Right here. And then D prime will be at negative 6, negative 6. Right down there. So it should be the exact same shape as the original, just a lot larger. There we go. Any questions so far? Not too bad, right? So there's no like special rule for like X, Y on this one. You just take the value of K and you just multiply everything by the value of K. So on number 3, anybody need more time on number 2? Okay, all right, I'll leave that up there a little bit longer. That's a good nut basket or not backpack. Jacqueline, here's the notes right here. What's the best non-backpack you guys have seen so far? Trash can? I saw a red wagon. That was fun. Somebody's got a red wagon. All right. So let's look at number 3. Problem number 3. Let's get our points on here. We'll take a look at what the rhombus looks like. Then we'll apply the factor of K. This will be our first reduction because now this number is less than 1. So it's going to get smaller.
So we can make it 9.
What's up? Well, no, it's going to be smaller than the original. So it'll be by half. So let's get our original rhombus on here first, though. So all the way to the left and then up to -10, 2, there's J. -2, 8 will be right here. There's K. 6, 2 is here. There's L. Yep. Thank you. Everybody's here today. That's awesome. We got JKL, and then M is at -2, -4. So that's left 2 and down 4. Right there. So we got J, K, L, and M. All right. So what you can do when you have a fraction with a numerator of 1, you could just divide all of them by 2. If your numerator is 1, you can just divide by the number on the denominator. Or if you want to, you can multiply each of them by the fraction, which gives you the same result. So basically, we're looking at half of -10 would be -5 for J prime. Half of 2 would be 1. For K prime, half of -2 is -1, and half of 8 is 4. For L prime, half of 6 is 3, and half of 2 is 1. And for the last one, M prime will have -1, -2. Just cut each of these numbers in half. Because the value of K is 1/2, so that means you want the original to be half the size. You want the new one to be half the size of the original. So you can either divide these all by 2 or multiply them by 1/2, gives you the same result. And we can graph our new point. So we got -5, 1. Right here. There's J prime. K prime is at -1, 4. Right here. L prime is at 3, 1. Right there. And then M prime is at -1, -2, right there. And so again, it's got the exact same shape as the original. It's just a smaller version of it. So now that we have that, I would like you to try number 4 on your own. And one of the values on number 4, it is an X value on number 4, will not be a whole number. Yeah.
What are you using?
What's that?
0.
The 0? What's 0 divided by 4? 0. There you go. One of those numbers, though, will not end up being a whole number. It is an X value, and that's okay. You just have to kind of put it in between the two that it ends up being. So try number 4. Everything gets divided by 4, or everything gets multiplied by 1/4, however you want to look at that. So take a couple minutes on number 4. It's going to be a triangle.
What do you do like that?
4.
What do you do if you have decimals?
Estimate where it goes on the graph. Did you get 2.5? There you go. So go in between 2 and 3, halfway in between. Oh, sorry, I was wrong. 2 of them end up being decimals, not just 1. So take a look at the numbers. W prime should be at -1, 2. Those are the coordinates for that one. X prime should be at 2.50. And then Y prime should be at -0.52. -2. Sorry, -0.5, -2 for Y prime. And when you graph it, it should just be a much smaller version of the original one. So if it doesn't have the exact same shape, then you know something went a little bit weird. So let's double check here. So we got -1, 2. So there's W prime. X prime is at 2.5. So here's 2. Halfway in between 2 and 3 is 2.5. So there's 2.50. We'll call that X prime. And then Y prime is at -0.5, -2. So that's going to be right there. There's Y prime. And that one definitely looks to be the same size, or not the same size, but the same shape as the other one. So just a lot smaller. Any questions about number 4? All right. Flip it over. Let's take a look at number 5. All right, number 5. We have a square. And by the way, look carefully on this one where your X and Y axes happen to be. So the X axis is here. The Y axis is way over here. So the point 0, 0 is to the left. So make sure that when you start graphing this one, you use the point 0, 0 to get to where you're going. So the origin is no longer in the center of our graph. Just because of the way it's shaped. So D is at 0, 0, so that's right here. E is at 2, 4, so that's over 2 and up 4. F is at 6, 2, so there's 3, 4, 5, 6, 1, 2. We got D, E, F. And then G is at 4, -2. Right there. So we've got our square. Now, before we actually figure out the image or the values of the image,
2.5.
it is. So the numerator being larger than the denominator, 5/2, means this will be an enlargement. Even though it's written as a fraction, it's not a fraction that's less than 1. It's a fraction greater than 1. Anything greater than 1 for K value means it's getting bigger. Now, if you want to, you can just take 5/2 and multiply it by all those values. So what you can do is just type in your fraction. So open up a fraction. You can write 5/2. And then go over and start multiplying. But we know multiplying by 0 doesn't change anything, so we may as well just keep D prime at 0, 0, because it's not going to change. But if we multiply by the values of E, 5/2 times 2 is 5. Then if you want to do that again, you can just type it in again and then multiply it by 4, which is 10. So we get 5/10 for E prime. So remember that you can just type in the fraction on your calculator and multiply by whatever value it is for the other one. If we multiply by 6, let's see, that's going to be 15. And if we multiply by 2, we already did that one, that was 5. We already multiplied by 4 as well, which was 10. And -2 will just make the 5 negative, so that'll be -5. So we're gonna have a square. Should be 5/2 times the size, which is 2.5 times bigger. Starting in the same place though. So D prime and D share a point. E is at 5/10, so that would be right 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's up to the top. There's E prime. F prime is all the way over at 15/5. So that's why the Y axis was moved over, so we could actually have room to get over 15. So 11, 12, 13, 14, 15, 1, 2, 3, 4, 5. So 15 is all the way to the right side. So F prime all the way to the right and up 5. And then G prime is at 10, -5. So Right there. There's G prime. So here's our new square. And you might notice when you start drawing your lines in here, the lines basically on the left side of the square kind of cover up the original lines because it's the same, it's actually just the same angle. Just like that. Ends up kind of looking like a baseball field on its side. So there's that. And right there. Cool. So go ahead and try number 6 on your own. Try number 6 on your own. And then we're going to skip to the very end and do 11 and 12, and then we'll be done with our notes. So number 6, and then we'll look at 11 and 12, then we're done. So our values for S prime, T prime, and U prime, there they are. -5, -1 for S prime, -4, -5 for T prime, 0, -3 for U prime. There it is. So that's it in terms of applying an enlargement or a reduction. There's 4 more problems on here. I will fill those out when I put them online, but we're not going to go over those as a class. Does anybody have any questions about what we've done so far?
No.
Does anybody need more time for number 6? All right, the last 2 that we're going to do are 11 and 12 though. Because with 11 and 12, kind of like with some other ones we've seen, it's going to ask you what is the actual rule that's being applied to make the transformation. So on number 11, we've got our original and we have our image. We got the pre-image and the image. I'm going to do red and blue like I've been doing. So all the regular ones are the pre-image. So the pre-image is larger and the image is smaller, which means we are looking here at a reduction.
140.
So in order to do this, I'm just going to write down a little bit of a note here. And I want you to write this down here as well. It's actually a pretty straightforward process. All you need to do is, here we go, pick an X or Y value from the pre-image and put it smaller this time. So just trying to remember the process here. So here to here and put it under the same X or Y value from the image. So pick an X or Y value from the pre-image, any X or Y value. Doesn't need to be both, just needs to be a single one. And then you are going to put that under the same X or Y value from the image. So for example, I should give an exception here. Don't use 0. 0 is not going to work. Any number, any X or Y value other than 0. So for example, if we choose this number here on the x-axis for E, this would be a value of 1, 2, 3, 4, 5, 6. Yeah? So we're going to put that underneath a value, the same value. So we're going to go 6 underneath. And then the value, the x value from E prime is at 1, 2.
1/3.
And so we have a scale factor of 2/6. However, what Ralph said is 1/3 because this does reduce. If the scale factor reduces, you need to reduce it. So this would then be equal to 1/3. So just put an arrow here. Scale factor is 1/3. And if you want, you can just type that into your calculator as a fraction. 2 over 6. Hit enter, and it'll give you the reduced fraction of 1/3. So the scale factor here is 1/3. I would like you to try the next one on your own for number 12. So here's our image. Our pre-image. What's that? Pick a random letter and pick one of the 2 numbers from it. Start with the pre-image. So this time the pre-image is the smaller one. The image is the larger one, so this is definitely an enlargement. Choose either an X or Y value from any of those on there, except for the Y value on X. Don't use 0. Never use 0 for your number. So follow the directions here. Pick an X or a Y value from the pre-image. Any X or Y value. Put it on the bottom of your fraction. Put it as your denominator. And then the numerator is the same X or Y value from the image. So take a moment on that. And everybody could choose a different one. As long as you don't choose the one that's at 0, everybody could choose a different number on there and you'll all end up with the same answer because the same thing happened to every single value to get from the pre-image to the image. Anybody have it? The scale factor? What are we saying? 4? Which numbers did you use? The ones for X? Okay. So just the X value, right? The X value for X. Okay. So if we put the 2 on the denominator, the image value is 1, 2, 3, 4, 5, 6, 7, 8. Yep. We got 8 there. 8 over 2 equals 4. Scale factor is 4. If you chose a Z value, you'd have, let's see. Ooh. So with Z, you could have a 1 or a -1 here. And then this one down here would be -4. So that would be -4 over -1 from the original. And -4 divided by -1 equals 4. So it doesn't actually matter which values you choose, as long as you got your image values above your pre-image values and you reduce it, it ends up equaling the same thing no matter what. Any questions about that? So pre-image or image value over pre-image value to figure out your scale factor. All right. So that's all we got. Let's go ahead and get your assignment handed out. That was your last